Hello and welcome to The Explainer. Today, we're jumping right into the really complex world of muscle dystrophy, a condition that all starts with a simple but pretty baffling question. So I want you to imagine this. A young child who's been hitting all their developmental milestones just suddenly starts finding it hard to get up off the floor. Now, this isn't just some phase. It's a clue. It's a sign that something really profound is going on inside their muscles. And this is exactly where our investigation kicks off. So, where does this puzzling weakness even start to show up? Well, for a lot of families, it begins with a very specific and what turns out to be a telltale sign.
Yeah, this very distinct movement is known as the Gowers maneuver. It's one of the classic early signs of Duchenne muscular dystrophy, or DMD, and it often shows up between the ages of 2 and 5. And listen, this isn't just clumsiness. It's actually a clever, unconscious way the body compensates for weakness in the big muscles, the ones around the hips and thighs. The child is literally using their arms to do the heavy lifting their leg muscles just can't handle anymore.
Okay, so this physical sign, that's our first big clue. But to really get what's going on, we have to go from the observable world, the playground, and zoom way, way in, deep inside the body's genetic blueprint. The term muscular dystrophy, it's not just a single disease. It's really an umbrella term for more than 30 different genetic conditions. But they all share this one common and pretty devastating feature. They cause muscles to get weaker and waste away over time. The root of the problem is buried deep within our genetic code. And in a lot of the most common types of muscular dystrophy, the investigation points to one key player, a protein called dystrophin. Honestly, the best way to think about it is this. If your muscle fibers are the bricks, dystrophin is the mortar holding it all together. It's basically a shock absorber, protecting the muscle cell from the stress of every single movement you make. And without that mortar, the whole structure just becomes incredibly fragile.
So here's how one tiny genetic error can set off this devastating chain reaction. It all starts with a mutation in the DMD gene. That's the blueprint for making dystrophin. Because of that one little mistake, little to no functional protein gets made. This makes the muscle cell walls, their membranes, unstable and leaky. So now every single contraction causes damage, creating this vicious cycle of cell death. And while the body tries its best to repair itself, it just can't keep up. Healthy muscle eventually gets replaced by scar tissue and fat. And that's where that progressive weakness really comes from.
Now, what's really fascinating here is that the type of error in that genetic blueprint can lead to wildly different outcomes. This isn't just one story, it's an entire spectrum of conditions. So, let's take Duchenne and Becker muscular dystrophy. Both are caused by faults in the exact same gene, but the outcomes are just worlds apart. With Duchenne, it starts early, progresses really fast, and that's because there's a complete absence of dystrophin. But with Becker, symptoms show up later and they progress much, much more slowly, often allowing for a near-normal lifespan, all because the body is still making some functional dystrophin. So what on earth causes such a huge difference? Well, the answer is pretty incredible. It lies in the type of genetic typo. In Duchenne, what you have is a frame shift mutation. This scrambles the genetic message so badly that the protein-making machinery just grinds to a halt. No functional protein at all. It really is like a computer file that's so corrupted it just won't open. But with Becker, the mutation is in frame. A piece of the code is missing, sure, but the rest of the message can still be read. The result is a dystrophin protein that's shorter, but it's still there and offers some protection. It's like a flawed file, but you can still open it and get the general idea. And it's really important to remember this whole story isn't just about dystrophin. There are other forms, like myotonic dystrophy, which are caused by totally different genetic glitches. In this case, it's an expanding repeat in the genetic code. This condition really shows how broad that term muscular dystrophy is because it doesn't just affect your skeletal muscles. It can also cause cataracts, heart rhythm problems, and a whole host of other issues across the body. So with this kind of complexity, how do you even begin to fight back? Well, it's definitely not a job for one person. It takes a whole coordinated team launching a multidisciplinary attack on a disease that hits the body from so many different angles. Because the disease affects the whole body, the care team has to be huge. A neurologist might be the quarterback, coordinating everything, but you also absolutely need a cardiologist for the heart muscle and a pulmonologist for the lungs. Physical therapists work tirelessly to maintain mobility, while other specialists like geneticists and nutritionists tackle the problem from their angles. And so, crucially, psychologists are there to support the immense emotional journey for both the patients and their families. And this right here is where the story gets incredibly hopeful, the way treatment has evolved. For decades, the main tool in the toolbox was corticosteroids to just slow down the muscle damage. But now we're in the era of targeted genetic therapies. I mean, get this. Exon-skipping drugs act like a kind of molecular patch, telling the cell to just skip over the genetic typo. This helps it create a shorter, but still functional, protein, basically turning a severe Duchenne mutation into something more like a milder Becker one. And even more revolutionary is gene replacement therapy, which uses a harmless virus to deliver a brand new working copy of the dystrophin gene right into the muscle cells. It's amazing stuff. But these incredible therapies, they're not the end of the story, not by a long shot. They're just the beginning. They've cracked open the door to a whole new horizon of hope, and researchers are now racing down several really exciting new paths to fight this disease.
Out on the frontier, the ideas get even more ambitious. Scientists are exploring CRISPR gene editing with the ultimate dream of permanently correcting the original typo right there in a patient's DNA. Another really cool strategy is to block myostatin. That's a protein that naturally puts the brakes on muscle growth to help the body build more strength. And a third, super clever approach involves reactivating a protein called utrophin, which is sort of a cousin to dystrophin, and getting it to step in and do the job its missing relative can't. We are really at a remarkable turning point. Science is shifting from just managing symptoms to actually fundamentally rewriting the code that causes these diseases. And that leads us to a profound new question. It's no longer a matter of if we can alter the course of muscular dystrophy, but how completely these new tools are going to rewrite the future for families all around the world. Thanks for joining this explainer.